What up, geometry students? We are going to do SOHCAHTOA with a calculator. Right triangles are so important to mathematics, to so many different fields that we need to kind of know side lengths of all different types of right triangles. So they were studied. Uh, they the ratios within certain triangles were produced, tables are put out, or things are programmed into calculators. Okay. Now you're going to need your calculator for this homework. So make sure you have it. Make sure your calculator is in degree mode. If you have a TI-84 graphing calculator, pop down, pop over to degree, press enter, make sure degree is selected, and then go ahead and quit out by pressing second quit. Okay, cool. Now, what you should be seeing is that if you type in sine 50, like I have here, you should get 0.766. If you don't, your calculator is not in degree mode. Cosine 50, 0.642. If you don't have that correct, your calculator is not in degree mode. Okay. And that's key, is that like when I find the sine of an angle, I'm going to be given the ratio of the opposite side length divided by the hypotenuse. Well, if I get 0.766, I'm really just assuming it's 0.766 over 1. So that means if I have a 50-degree angle in a right triangle, this would be 40, and the sine of 50 degrees is 0.766 over 1, then I know one representative of a triangle with 50-degree angles with a hypotenuse of 1, the opposite would be 0.766 versus the adjacent would be 0.642, because the cosine of an angle equals the adjacent over the hypotenuse. If I type in the cosine of 50 degrees and I get 0.642 or 0.643, doesn't matter. We would say that, oh, if I have an hypotenuse of 1, the adjacent would be 0.642. Cool. So these are triangles with a hypotenuse of 1. What are their side lengths? One more thing we could say. Watch this. We know that this angle has to be 40 degrees. What would I get if I typed in the sine of 40? What if I typed in the sine of 40 degrees? Well, I bet you I'm going to get 0.642 over 1, because the 40-degree angle is in the same triangle as the 50-degree angle. So watch and see. The sine of 40 degrees is the same as the cosine of 50 degrees. Look at that. And if I do the cosine of 40 degrees, I'm going to get the same as this sine of 50 degrees, because it would be these side lengths in this right triangle. Okay. So, it's up to you if you want to just use 65, or you could go ahead and use 25. And you could do the sine of 65, and that's going to be the opposite over the hypotenuse. Well, opposite of 65 is A. Realize that that's the same as the cosine of 25, which would be the adjacent over the hypotenuse. Well, we're referring to this length A. So I could type in the sine of 65 or the cosine of 25, and I get 0.906 over 1. Well, I already have the hypotenuse as 1, so we're good. So A must be 0.906. All right, and now what if I do B? Well, I can see that B is adjacent to 65 or B is opposite 25. You may choose to either do the cosine of 65 to get the ratio in this triangle with a hypotenuse of 1, or the sine of 25. And then we got cosine 65 or the sine of 25. They're going to be the same because they're referring to the same ratio in the same triangle, and we get to 0.4226. Just put dots after this. Put dots after this. Always fun to do the following. Use the Pythagorean theorem. A squared plus B squared, press enter, squared, equals C squared. Yeah, we're a little off, but we can see that's really, really close to 1. All right. If this is 60, this is 30. Opposite, here's my hypotenuse, which is 1. So opposite of 60 would be A, which is the same as the adjacent to 30, which would be A over 1 in both situations. The sine of 60 is this weird number, 0.866. The cosine of 30 is that same weird number, 0.866. We will discover what that number is in the future. It's actually the square root of 3/4, which is cool. And if we wanted to talk about B, we can either say the cosine of 60, because it's adjacent to 60, or the sine of 30, which is opposite of 30, divided by the hypotenuse. So the cosine of 60 or the sine of 30 is the same, and we're going to get 1/2, and we are going to talk about why that is that nice number 1/2 in the future. Cool. Okay. Now, we are going to solve these triangles. We want to find the missing angle and the missing side lengths. There is a very geometric way of doing this that we kind of are building towards understanding through last unit and this unit. And then there's a more algebraic way of doing this. And I'd like us to be able to handle both. Now, we want your answers to be both in a calculator ready form as well as a decimal form. Let me show you how I do this question. First thing, I know this is 40 degrees. 40 plus 90 is 130. This has to be 50, or these two angles have to add up to equal 90. Cool. Now, here's what I could do. This would be like the geometric approach, or like the long way. No, I'm not going to call it the long way. Here's the geometric approach. Let's start with 40 degrees. Let's find the sine and the cosine of 40. Cool. You now have a small triangle with an hypotenuse of 1, whose, make sure you label this correctly, whose opposite side is 0.6427. I'm going to put dots, that way you use the entire decimal, and whose adjacent side is 0.766. Okay, cool. Well, if I wanted to take this and make it that, what would I do? I would multiply everything by 4. So you could take this number and multiply it by 4, and you get 2.571. You can take this number and multiply it by 4. So this is the scaling of 4. Take this number and multiply it by 4, and you get 0.3064, which is this number right here. Now, notice how you could have said this number was the sine of 40. You could have said this number was the cosine of 40. Well, you could just multiply the sine of 40 by 4. You can multiply the cosine of 40 by 4, and here it is. Here's the version. Okay? Now, that is the geometric approach. Here's the algebraic approach, which I consider the more elegant way. And you know what? I am not going to say that anymore. It is not the more elegant way. I said that in the notes. I don't like it. It is the more algebraic way, where you could say, oh, well, I know that the sine of 40 degrees, this ratio that will be given, has to equal the opposite over the hypotenuse. Well, the opposite over the hypotenuse in this triangle is a over 4. So I'm going to change this to a over 4. And then I'm going to say, oh, I can just multiply both sides by 4. And I get 4 sine 40 is a. You could say that the cosine of 40 degrees, and also we can do this with 50 degrees with sine and cosine to get b with sine and a with cosine. Say the cosine of 40 degrees is adjacent over hypotenuse. Cosine of 40 degrees is the adjacent side b over the hypotenuse of 4, and you can then multiply both sides by 4 to get that 4 cosine 40 another way. This is kind of like the more algebraic approach versus the more geometric approach, which is like start with a smaller and then scale. All right, so if we did the sine of 50, that would have been that 0.766 value, which you could scale. If you did the cosine of 50, that would have also been this 0.6427 number, which you can also scale. All right, so I think this one I'm going to do the geometric approach, and then the next one I'm going to do the more like algebraic, maybe a little bit faster approach. Cool. This is 75, so D must be 15 degrees. Let's just focus on the 75, and then I'll just repeat everything. I know for the triangle with a hypotenuse of 1, that this would be the sine of 75 degrees, and this would be the cosine of 75 degrees. Or you could just type in the sine of 75 and the cosine of 75. Understand those ratios. I can write it out. The sine of 75 equals 0.965 over 1. That's the opposite over the hypotenuse. So opposite is 0.965. Hypotenuse is 1. Cosine of 75 is 0.2588 over 1, which is the adjacent over the hypotenuse. So the adjacent is 0.2588 over 1. We can then take this triangle and scale things by multiplying by 6, which means D would be cosine of 75 times 6. E would be sine of 75 times 6. That's 5.795. And this is the cosine of 75 times 6. That's 1.552. I want to make sure things make sense. D should be the smaller one. E should be the longer one. Okay, that works out. We're good. We just scaled our smaller triangle. And if you checked with the Pythagorean theorem, d squared plus e squared will equal 6 squared, which is fun to kind of do. D squared plus e squared equals 36. Could we have also used this angle 15? Yes, if we use this angle 15, we would have found that this was the sine of 15. This was the cosine of 15. We could have taken 6 and multiplied by the sine of 15. We would have gotten that same number. We could have taken 6 and multiplied by the cosine of 15. And we would have gotten that same number. Okay. I'm going to do it the more algebraic, maybe the quicker approach. We got this is 27. 27 taken away from 90 is going to be 63. So R is 63. Cool. Okay. Hypotenuse is 3. Great. Well, let's start with understanding that Q is opposite of 27 and R is adjacent to 27. Great. All right. So I know the sine of 27 gives me the ratio of the opposite over the hypotenuse. Well, in this triangle, this ratio will have to equal this triangle's ratio of Q over 3. Okay, great. Q will equal, multiply by 3, multiply by 3. 3 times the sine of 27. Use my calculator, get that answer. And the cosine of 27, which will equal the ratio of the adjacent over the hypotenuse for a triangle with a 27 degree. In this triangle, that ratio is R over 3. Well, multiply by 3 and we get R. We could have done the same thing with 63. This is going to be opposite 63. This is going to be adjacent 63. So we would have found that we would have scaled the sine of 63 or the cosine of 63, and we would get the same thing as the cosine of 27 and the sine of 27. So let's just do it really quickly. 3 cosine 27, which is the same as 3 sine 63. And then 3 sine 27 is going to be the same as 3 cosine 63 because it's in the same triangle. So it's referring to the same ratios times 3. 1.361. And if we use these in the Pythagorean theorem, we see that this squared plus this squared actually equals 3 squared. All right, now we're going to make it harder on you. This is not the hypotenuse, this is the adjacent side. Okay. Now let's do the geometric way here. Let's do the algebraic way here and understand the two different ways you could do it. We have this angle 37. So that means this angle has to be 53. Cool. Let's start with the geometric approach, which is if we have a small triangle with 37 in it, we can do the sine and the cosine. And I get 0.6018, which is the sine of 37, making sure we know that this is opposite 37. And that's going to be the ratio over 1. So that means the opposite is 0.6018. The hypotenuse is 1. And the cosine of 37 is 0.798 over 1. So boom, that's 1 there and good there. Now, this is 4. Ugh. What? How can we take 0.6086018 and turn it into 4? Well, we have to figure out how many times bigger 4 is compared to 0.6018. What do? We divide. So 4 divided by 0.6018 is how many times bigger this triangle is compared to this triangle. So that's our scale factor. It ends up not being a nice number, sure, but that's what we got. 4 divided by the sine of 37. Cool. That's our scale factor. So that means we need to multiply everything by 6.646. Okay, well, we need to take 1 and multiply it by 6.646. Which I'm going to do in a second. Okay, so that would be z, which is 1 multiplied by 6.646, or 1 multiplied by 4 divided by the sine of 37. Okay, what about y? Well, I need to take this cosine of 37 and multiply that by 6.646. So I can take 0.798 and multiply it by 6.646, which is the same as taking the cosine of 37 and multiplying it by 4 over the sine of 37. Okay. And I get 5.308. Now, I'm not sure. I have no idea. Is this right? There's a bunch of decimals. I never like having just a bunch of decimals. What can I do to make sure? Use the Pythagorean theorem. 4 squared plus y squared will equal z squared. Okay, 4 squared plus, don't use the simplified, use the full one, y squared should equal z squared. Hooray. We did it. All right. What's the more algebraic approach? And of course, we could have done this with 53 if we wanted to. We would have just used the sine of 53 here. We'd have done the cosine of 53 here, which means we would have found the scale factor by taking 4 and dividing it by the cosine of 53 to figure out how many times bigger that one is. Okay, the algebraic approach. Well, we got angle B must be 80. Cool. A is opposite of 10 degrees. C is the hypotenuse. 8 is adjacent 10 degrees. This is important. Make sure you always label the hypotenuse first. Okay, here's the algebraic way. Well, if I look at my ratio of sine of 10 degrees, I know that has to equal A over C in this triangle. Well, it's like, I don't have A or C. That doesn't really help me. Okay, well, then let's look at the cosine of 10 degrees. Okay, well, the cosine of 10 degrees has to equal 8 over c. Okay. 8 over c has to equal cosine of 10 over 1. Oh, look, I can cross multiply and divide. I get c times the cosine of 10 degrees equals 8. I can say c equals 8 divided by the cosine of 10 degrees. Cool. So let's see. If I can't use sine and cosine, because like I can actually use sine now if I wanted to. Now that I know what c is, I know that a equals c times the sine of 10 degrees. I know what c is, so I could do 8 over the cosine of 10 degrees times the sine of 10 degrees, but watch what is going to happen. There's something else besides sine and cosine out there. And that, my friends, is tangent. And I could say the tangent of 10 degrees equals the opposite over the adjacent. And I could say, oh, wait, multiply by 8, multiply by 8. 8 times the tangent of 10 degrees is A. I bet you this is equal to 8 times the tangent of 10 degrees. And we could also double check these with the other angle B, which is 80 degrees. And if you don't like doing it this way, please start with the smaller triangles and understand the scaling of things. So 8 divided by the cosine of 10 is 8.123. 8 times the tangent of 10 is 1.410. 8 divided by the cosine of 10 times the sine of 10 is 1.4106. Yeah, I honestly like the scaling way better now that I think about it. Um, I used to always do algebraic, like, oh, just set up the correct things and like do it correctly. But like, I don't know, I feel like I kind of understand things a little bit better this way. So I'm going to go back to geometry. I'll do both. So let's say we'll start with our unit triangle with a hypotenuse of 1. We'll do the sine of 41. We'll do the cosine of 41, making sure we have the correct angles listed. The sine of 41 is opposite over hypotenuse. So since the sine of 41 is 0.656 over 1, I know the opposite is the 0.656, the hypotenuse 1. The adjacent is 0.574. The hypotenuse is 1. Cool. Well, we need to scale this. What is the scale factor? Well, how many times bigger is 1 compared to 0.656? Divide them. So 1 divided by 0.656 is the scale factor, or 1 divided by the sine of 41 is the scale factor. And you get that the scale factor is times 1.524. Okay, so if you want to start knowing that this is the sine of 41, this is the cosine of 41, you know that u is going to be uh, the cosine of 41 times the scale factor, which is 1 over the sine of 41. W is going to be 1 times the scale factor, 1 over the sine of 41. Cool. There's my scale factor. You could have also used decimals. You would have taken the 0.754 number and multiply it by 1.542. Sorry, 524. And then this would have been 1 multiplied by the scale factor, 1.524. And you would have gotten 0.754. I'm better than that. This number times this number would have been U, 1.150. And then this number is W, 1.524. Okay, so like, do we like this? Does it feel right? Are you sure? Use the Pythag. I don't know why this is happening. It's annoying. Use the Pythagorean theorem. 1.50 squared plus 1 squared equals 1.52 squared. So this is A, this is U squared plus 1 squared equals W squared. 1.524 squared. It's beautiful. This is 41. This has to be 49. Everything could have been done the same way. If I were going to do this the algebraic way, I would have said the sine of 41 equals 1 over W. Cross multiply divide. W equals 1 divided by the sine of 41. That's what I got here. To find U, I probably would have used tangent. Tangent of 41 equals the opposite over the adjacent, which means cross multiply divide. U would equal 1 over the tangent of 41. I bet you this is the same as 1 over the tangent of 41. And it is. It's like just like really beautiful. When we look into tangent being sine over cosine, which makes sense, which we really haven't done yet, but we can just kind of discover how, there's only 3 sides. They have to be related to each other. This being the same as this just makes sense. I got 3 different triangles. They all have an angle of 60 degrees in them. It's a very easy way to do this. Start with this triangle here, scale it. This is where like the geometric approach is just a lot nicer than maybe like setting up and solving so many equations. I'll show you why. All right, so we already have this small one with the hypotenuse of 1. The sine of 60, the cosine, we already kind of looked at this one. We're going to see it more often. Sine of 60, 0.866. Over 1, the cosine of 60, half over 1. Well, this triangle is this triangle scaled. Same with that triangle. What's the scale factor? Well, 0.866 has to turn into 3. How do you figure that out? You divide the two to see how many times 3 is bigger than 0.866. How many times is 4? I mean, that's actually easy. 8. Like 4 divided by a half, you could have figured out. So the scale factor for the middle one is a little bit trickier. It's 3 over the sine of 60 degrees. And the scale factor for the bottom, the biggest one, easy because it's a half, 4 divided by half, which is 8. So cool. C, which is 1, needs to be multiplied by 3 over the sine of 60. B would be a half multiplied by 3 over the sine of 60, which is the scale factor. So we're just scaling everything. And let's get some numbers. 3 over the sine of 60 is the scale factor. So that's going to be this length. And then this length is that times a half. Cool. All right, this scale factor is 8. So this was the sine of 60. So I'm going to multiply 1 by 8, get 8. I'm going to multiply the sine of 60 by 8 to get that. And if you did this algebraically, you'll get the same answers. All you tutors out there are doing this algebraically, and that's great, but I don't know, I kind of just like this better. Now, let's figure out some ratios. A to C. Oh, wait, that's got to be just 0.866. Okay, cool. A to B. A to B. Okay, 0.866 divided by 0.5. All right, so that's that 0.866 divided by 0.5. So that's the sine 60 divided by the cosine 60. So 1.732. Okay, cool. A, we said, was the sine of 60, and B was the cosine of 60. Oh, wait. Isn't A over B the tangent of 60? Hold on a second. What's the tangent of 60? Oh, what? That's crazy. All right, cool. Let's use our values here. We got that A is 3. C is this 3.464. Cool, let's divide those two. We got A is 3, B is 1.732. Cool, cool. Let's get that. Whoa. Is that the same? Whoa. Okay. I hope this works. Okay, 3 divided by that 3.464 number, which is 3 over the sine of 60. Okay. And I got 0.8 6, 6. Okay, cool. 0.86. Oh, wow. 3 divided by this 1.732 number. Wow. It's like, this is kind of blowing my mind. I'm not sure how. I'm not sure how. It's the square root of 3. Oh, that's why. I'm laughing because I just had a mathematical revelation. I don't, and it's funny. Oh, wait, hold on. That's the same as this. Of course. Sorry. Oh, wait, the numbers are the same. What's going on? And it's b is the square root of 3. Oh my gosh, I got it. I got it. B actually ends up being the square root of 3. And C it actually ends up being double the square root of 3. Oh, wow, that's great. Wow. Okay, don't worry about it. You didn't have to know that that's the square root of 3, but this is a great, great problem that I came up with accidentally. Okay, I digress. What's B? 4? Oh man, that was really nice. All right, let's do the last one. 6.928 divided by 8. Yep. 1. 8 sine 60 divided by 8. Isn't that just the sine of 60? Isn't that just 0.866? Oh yeah. What about here? 8 sine 60 divided by 4 is 2 sine 60, which is the square root of 3. Oh my gosh, this is so great. 8 sine 60 divided by 4 is 1.732. What do we notice? Of course, guys, they're all the same shaped triangle. These are all 30, 60, 90 triangles. These are all the same shapes. They're all similar. What must be true? The ratios of the side lengths to these similar triangles must be consistent. So if you do A over B in this one, it's going to be the same as A over B in this one, which is the same as A over B in this one. If you do B over C here, you'll get the same as B over C here. You get the same as B over C here, whatever that is. So this is just showing you guys similarity, ratios, scaling. Don't worry about the root 3 and why I laughed a lot, but that was fantastic. And uh, we're just scaling things, and we're just studying right triangles, and we understand ratios must always be consistent. Okay? This is fun. I'll see you out there. Peace.